and puzzle of the 2D shapes. And this, of course, is a lesson that stems from the previous lesson that we had on constructions last week, where we learned different ways of constructing angles as well as quadrilaterals. But now today we are going to limit our lesson only to congruent triangles. And of course, please feel free to ask if you have got any question. And I believe that by the end of this lesson, you should be able to establish, the different conditions for congruent triangles. There will be conditions that we'll look at. But the key question for now is, how do we define congruency in relation to triangles? What is congruency? How do we define congruency? And of course, we can simply define congruency by saying that two triangles are congruent if and only if they have exactly the same shape and the same size. We're talking here about the shape and the size. Some people will start with the size, it's fine. You can say two triangles are congruent if they have the same size and the same shape. This means that the one triangle must be able to fit exactly on top of the other triangle. Just as your hand can be able to fit, your right hand can be able to fit exactly on top of the left hand. Now, you must be able to see again that the corresponding sides must be equal as well as the corresponding angles. And of course, this is an example that we have. If you look at the following pairs of triangles, we have a triangle ABC as well as triangle DEF. We also have triangle GIH and triangle JKN. Now, those are the two pairs of triangles that I want to focus on this morning. Let's focus on the first pair of triangles, that is triangle ABC and triangle DEF. If you look at these two triangles, you are given sides. You can see that you are given sides as well as angles. If you look at the side AB, it has got one line there, equivalent to DE. This tells us that the side AB in the first triangle is equal to DE. You can see that because of one line. So AB in the first triangle is equal to DE in the second triangle. In the same note, we also have the line BC. As you can see there, there's got two lines there. The line BC is equal to the line EF. The line BC is equal to the line EF. And of course, the last one will be AC. As you can see, it has got three lines there. On AC. AC will be equal to EF. And because we've got three sets of lines which are equal, or sides, you can call them sides. Because of the three sides, corresponding sides which are equal, AB equal to DE, BC equal to EF, and AC equal to DF. Then we can make a conclusion. We can conclude that therefore triangle ABC is congruent to triangle DEF. And of course, the reason for this is the sides. You've got three sides or three corresponding sides which are equal. I will show you as we carry on how do you write how do you give the reasons, how do you put it in your bracket. But before we get there, I want us to focus now on the second pair of triangles. We're talking about triangle GHI and triangle JKL. Again, in the same note, you can see that GI in the first triangle is equal to JL in the second triangle, meaning that the side here, GI, will be equal to JL or LJ if you want to call it. Then the second side will be GH. As you can see, GH is equal to JK in the second triangle. And of course, the last side is HI. And as you can see, because of the three lines there, HI is equal to LK. Now, what does this tell us? This tells us that the two triangles, triangle GHI is congruent to triangle JKL. Why? Because the two triangles, if you can look at them, have got the same shape and the same size. So how do we know they've got the same size? Because we've been given that the three corresponding sides are equal. Let me repeat, GI is equal to JL, and the side GH is equal to the side JK, and the side HI is equal to the side KL. Now, these two pairs of corresponding of triangles with corresponding sides that are equal, we say that they are congruent. In other words, if you go to the first pair again, lastly, triangle ABC will be congruent to triangle DEF, whereas triangle GHI is congruent to triangle JKN. Now, right. We say that triangle ABC, as we have already indicated, is congruent to DEF, and triangle GHI is congruent to triangle JKN. And each pair, the corresponding sides and corresponding angles have to be equal. Now you can see congruency. We have got three lines there, which represent, this is the symbol for congruency. It's more like an equal sign, but then you add the third line. So this sign indicates that the figures are congruent. This is the sign for congruency. Don't confuse this with the sign for similarity. Right. So these were the two pairs of the triangles that we were looking at. And of course, I want us to carry on with the next conclusion. We are emphasizing that triangles are congruent if they meet the following conditions. The first condition is that the three sides of one triangle must be equal to the corresponding sides of the other triangle. So that is the example that I've just given you now. The previous example where I have shown you that the three sides of the first triangle are equal to the corresponding three sides of the other triangle. If you look at ABC, triangle ABC and triangle DEF, as well as triangle GHI and triangle JKL. So therefore, the first condition is that the three sides of one triangle must be equal to the corresponding sides of the other triangle. And we mentioned this in bracket. In bracket, you can put side, side, side. This means that you are emphasizing that the three sides of one triangle are equal to the corresponding sides of the other triangle. And of course, we come to the second condition, which says two sides and the included angle of one triangle are equal to the corresponding sides and an angle of another triangle. So if you have got two sides in one triangle, which are equal to the corresponding two sides of the other triangle, together with an angle, one angle which is equal to another angle of the second triangle, then you can conclude that the two triangles are congruent. And the reason being, you'll have side, angle, and a side, because we've got two sides and an angle in each triangle. And of course, two angles and a side. So now you come to two angles and a side. So if you have two angles and a side of the one triangle, which are equal to two corresponding angles and a side of the other triangle, the two are congruent. So we're talking about congruence. Now, that is the third condition for congruence. And the last one, the last condition is where you have the right angle, the hypotenuse side, and another side which are equal to the corresponding right angle, the hypotenuse, and the side of the other triangle. So if you have two triangles, one with a right angle and the other with a right angle, then you know that the two right angles are equal. And on the hypotenuse side, the side that is opposite the right angle. And of course, the last side, then you can conclude. We name this RHS, meaning that is the right angle. The R stands for the right angle. The H stands for the hypotenuse side. And of course, the S means is the remaining side. So the two corresponding sides of the triangle. So basically, you've got only four conditions that you can talk about in as far as congruency is concerned. Now, represented in triangles, here are the conditions. As you can see, we have triangle ABC and triangle DEF. It should be clear at this point that triangle ABC is congruent to triangle DEF. The reason being side, side, and side. Why? Because AB is equal to DE, and AC is equal to DF, and BC is equal to EF. So here in the first category, we're talking only about the side. And the second category, if you can check, again, we've got ABC, that's a triangle, and we've got PQR, the second triangle, or QRP. It's up to you how you start. If you look at the second triangle, you can see that we've got angle B in the first, which is equal to angle R in the second triangle. You also have the side AB equal to the side QR. And of course, the last side BC is equal to RP. So therefore, triangle ABC is congruent to triangle QRP. The reason being, you've got two sides there. So how do you write it? You write side, and then angle, and a side. And then, of course, the third one, you've got two pairs there of triangles. You've got ABC and ZYX. You can see that B is equal, angle B is equal to angle Y. And of course, angle C is also equal to angle X. So you already have two angles there. The first angle is B, corresponding angle is Y. And you also have angle C, which is equal to angle X. And of course, you also have a side, BC, which is equal to XY or YX. Then you can conclude that triangle ABC is congruent to triangle ZYX. The reason being SAA. Others put it as AAS. So it's really up to you. You can write SAA, meaning the side, angle, and angle. And of course, the last condition there, as you can see, we should know the right angle triangle at this point. You have the right angle triangle, which is ABC. And of course, the last one is LMN. That is the two pairs of triangles. You can see that angle B is equal to angle N because both of them are 90 degrees. You're given the hypotenuse side, which is AC, equal to LN. That is given. And the last side that is given, BC, is equal to MN. And of course, this means that triangle ABC is congruent to triangle LMN. The reason being, you've got 90 degrees, hypotenuse side, the side. And of course, you can simply write it as RHS. So those are the four conditions that I wanted us to talk about this morning. And of course, I hope that I'm not fast. I'm going to now zoom directly into an example. We have an example here. JN and KM are straight lines. They are given there. You need to prove that triangle JLK is congruent to triangle NLM. And you are also given that JK is equal to MN. Now, if you look at the following triangle, you can see that in triangle JLK and triangle NLM, JK is equal to MN. Why? That is the information that you are given. You are given the information that JK is equal to MN. What else are you given? You're also given angle L1 is equal to angle 2. If you remember in geometry, we have taught you about the vertically opposite angles. So angle L1 here and angle L2 are equal because they are vertically opposite angles. And the last angle, of course, will be angle J, which is equal to angle M. And that information is given to you. So you've got one side, or a side with the corresponding side JK equal to MN. You've got two angles there, and two pairs of angles, L1 equal to L2. And of course, the last angle will be J equal to M. They are given. Therefore, you can make a conclusion. The conclusion is triangle JLK will be congruent to triangle NLM. And of course, this means you've got one side and two angles. So you can write it as SAA or AAS. Can I pause for questions? If there's any question at this point, please engage me now before we proceed to the next example on congruency. All right, I see there are two participants. Anyone can come in? Anyone? Yari, you can recognize any
why is angle J equal to angle N?
All right. Okay, why is angle J equal to angle N? Who's speaking now? What's your name?
Yeah.
Yes, angle J is equal to angle N because you are given that information. This is the information that is given to you. If you can check, maybe the example, we said that JN and KM are straight to prove congruence, but you are given that the line J is also given that J, that information is given to you. So that is the reason.
Okay, thank you. Thank you.
Thank you very much. Is there any other question at this point? Right. In the absence of the question, let's proceed now. You can know this. From this, we can deduce that the remaining corresponding parts of the triangles will be equal. Example, angle K will be equal to angle M. JL will be equal to LM. And KL will be equal to LM because we've already proven a congruence, meaning that the two triangles have got the same size and the same shape. So that is the first example that I've just given you now. Now I'm going to proceed. I hope that I'm not fast. I hope that everyone is following. I'm just going to proceed to the next example because I've got 3 examples that I want to look at this morning. Now, example 2. You can see that with triangles again. In fact, it's 3 triangles, but I want you to limit yourself to 2 triangles. I'm sure you can see 3 triangles on the figure there. The bigger triangle, which is PQN. You've got 2 triangles, PQM and PRM. So you've got the bigger triangle, which is PQR. That's the biggest one. But I want you to limit yourself to only 2 triangles. It is given that M1 is equal to M2. That information is given. It is also given that PQ, the line PQ is equal to the line PR. That information is given. Now, we want you to prove that triangle PQM is congruent to triangle PRM. But at the same time, we want you to also prove that QM, the line QM, is equal to the line NR. Now, let's start. What do we do? Of course, we first need to prove that M1 is equal to M2, which is 90 degrees. So that we can prove that the triangles are congruent using the 90 degrees. Now, what are we going to do? We're going to say M1 plus M2 gives you 180 degrees. Who can tell me why? Why is M1 plus M2 equal to 180 degrees? Who can tell me? M1, yes, Yaha, your hand is up.
Because angles on a straight line add up to 180 degrees.
Exactly. Angles on a straight line add up to 180 degrees. And of course, we know that M1 is equal to M2. How do we know? The information is given to us. That is given. Therefore, in this triangle PQM and triangle PRM, the 2 triangles, we also know that PQ is equal to PR. That information is also given to us. All right. Now that we know that the 2 conditions, the first one is the angle. We know now M1 is equal to M2, both of which are 90 degrees because they are on a straight line. And of course, we also know that PQ is equal to PR. So we've got an angle, the pair of angles, the pair of sides. Now, just to go back again, you have now proven that M1 is equal to M2. We've done that. So we know that PQ is equal to PR. Therefore, M1 is equal to M2, which is 90. We've proved that. PM is equal to PM. Those are common sides. If we go back to the triangle, let's look at the common side. Can you see two triangles there? PQM and PRM. If you separate the two triangles, you will be able to see that PM is common. We say that PM is a common side. So now we've proved the first pair of angles, the line PQ equal to PR. Now we know that PM is common. So how many sides do we have? We have got two sides there and an angle. Now we can conclude that triangle PQM is congruent to triangle PRM. We have 90 degrees that we have already proved. And then, of course, from this particular exercise A, because we also had the second question there, B. Example 2B, we needed to prove that QM is equal to MR. Now we've got PQ, one side which is equal to PR. You also have PM, which is common. You also have M1, which is equal to M2, both of which are 90 degrees. Therefore, you can conclude that QM is equal to MR. Because the line that bisects, PM bisects QR. We spoke about the line that bisects another line. So PM is obviously bisecting QR because it forms 90 degrees at N. Therefore, this means that QM will be equal to MR. Again, the reason being the two triangles are congruent. So we've proved congruency there. Let me proceed to the next one, which is example 3. Now let's look at the following example now. We have got AE and BD, both of which are now straight lines. And of course, BC is equal to CD. We need to prove that triangle ABC is congruent to triangle EDC. That is what we need to prove. But at the same time, we also need to prove that AB is parallel to DE. So remember, parallel lines. Parallel lines, those are the two lines which cannot meet. Now, how do you proceed to prove that the two triangles are congruent? You can start by looking at the information that is given. Obviously, we are given the line AC, and we are told that the line AC is equal to the line, and of course, we are given that information. But equally, we can look at the two angles are equal. And of course, we are also given that the line BC is equal to the line DC, or C, another side, BC and CD. So those are the two corresponding sides, which are equal. And that information, as I've said, is given. That information is given. Now we proceed to the B, to prove that AB is parallel to DE. Now, if you can check, you are told here that since the two triangles are congruent, it follows that angle A will be equal to angle E. And it also follows that angle B will be equal to angle D, because we've already proved congruence. Remember that congruency was said same size and shape. Then once you have proved congruency, then it means even the corresponding angles will be equal. We've already proved that C1 is equal to C2. And because these are vertically opposite angles. And we've also show the information that is given. AC is equal to CE, BC equal to this. So basically we've proved congruence. So the two triangles have the same shape and the same size. So if angle C1 is equal to angle C2, then it follows that angle B will be equal to angle D, and of course angle A will be equal to angle E. But equally, if these two angles are equal, then it follows that the line AB will be parallel to the line DE. If you look at those two sets, angle A and angle E, those are alternate angles. Alternate angles are equal. Therefore, AB is parallel to DE because we have proved that A and E, angle A and E, angle E are equal. And we proved that which follows from congruence. So without any waste of time, I'm just going to give you an activity. I want us to look at the following activity. For each of these figures below, state whether the pairs of triangles are congruent or not. If they are congruent, state the reason for congruency, and also the pairs of equal angles and equal sides. So you need to prove congruency. We've got three triangles or three pairs of triangles. I want you to prove congruency then. Now let's focus on the first one. How many triangles do we have? Two, ABD and BDC. I want you to prove congruency there. Are the two triangles congruent? Why do you say so? Can I get a comment? Are the two triangles congruent? Or you can choose any triangle. Yes?
Yes, so they are congruent because the sides AD equals to the sides of BC, sir.
Okay.
And then the
How
side.
do you know AD is equal to BC?
Sorry?
How do you know AD is equal to BC?
So because it's indicated to us, it shows us.
Exactly.
And then sides AB equals to DC.
Okay.
And then the opposite angles equals to angle C because opposite angles are congruent or the same.
All right. I agree with you, but I just want to caution you. You cannot make a conclusion based on the opposite angles. The reason being, you need to prove congruence in this case. At this point, we don't know exactly whether the opposite angles are equal. But of course, you can prove it as follows. You've got the line AB, which is equal to the line CB. You also have the line AD, which is equal to CD, and those lines are given. I'm talking about the two triangles. But there's one line that we forgot to mention. The line BD. Can you see the line BD?
Yes, sir.
That line is common in both triangles. If you separate the two triangles, you'll be able to see that the line BD is common. So you can make a conclusion based on information that is given to you. All right. I know that once you have proved congruency, yes, you will conclude at the end of the day that angle A will be equal to angle C. But at this point, we are looking at the sides. We are given the sides. You've got two pairs of corresponding sides, but you also have the common side, which is BD. So therefore, that triangle, yes, the two triangles are congruent. The reason being side, side, side. Does it make sense?
Yes, sir. Thank you, sir.
Let's go to the second one, number two. Harry, if you can recognize Tino. Tino, your hand is up. Let's go to Tino. Talk to me about the second pair. Again, triangle EFG and MNN. Yes, Tino?
It's because of the angles all 90 degrees.
Okay, yes, I can see the pair of 90 degrees there, yes. What else?
And the 47 degrees.
Yes.
Oh, no, sir, it's not really congruent, sir, because the other side is 47 and the other one is 43, sir.
Okay. So you are saying they are not congruent, the two angles, 47 and 43.
Yes, sir.
All right. Remember, let me mention something to you, Tino. How do you prove congruence in this case? You are given 47 degrees in the first triangle. In the second triangle, you are given 43 degrees. Now, what do you need to do? You need to find the third angle. Right. Now, the third angle there, if you add 47 and 90, if you add the two, 47 degrees and 90 degrees, and you will see that this angle in here will be 43 degrees. And
Yes.
And the same goes for the second triangle. If you add 90 and 43, and then you subtract that from 180, you will see that L will be 47. Can you see that?
Oh,
So you
yes,
will
sir.
have, yes, so you will have a side which is given, that's FG, and you also have another side that is given there. Then of course,
Oh,
yes, then you'll have 90 degrees. So you can conclude that the two triangles will be definitely be congruent. As you can see, you've got 90 degrees, you've got 47 degrees, you'll also have 43 degrees there. If the same goes for the last one, you have 90 degrees, 43, and 47 at end. So you can make a conclusion that the two triangles are congruent.
okay. Thank you, sir.
You can use, or you can use even the right angle as well. Right. And then, of course, the last one, the third one is not the last, but the third. Triangle LNO and triangle OMN. Are the two triangles congruent? Yes, the two triangles are congruent. Why do we say so? We are given the line LM, which is equal to NO. The two lines are equal, but equally we are given the angle NOL, which is 90 degrees. That is equal to angle OLM, also 90 degrees. And if you separate the two triangles, you will see that LO is a common side. Then you will have a side which is given. You'll have a common side again, and then you'll have the angle which is given there. And of course, this can be side, angle, side. So the two triangles are congruent. And of course, the last pair of triangles, 4, 5, and 6, equally. We can make a conclusion there with the first one. If you can see, UZ and VY are straight lines. Now, you are given that VU is equal to ZY. You are also given that VW is equal to WY. But at the same time, you are given a right angle there. At ZWY, that's a right angle. VWY, the first angle, that's also a right angle. And of course, you can make a conclusion without any delay that the two triangles, triangle UWV, is congruent to triangle ZWY. You have got two sides and an angle. And of course, the other one is the right angle. You can use the right angle, hypotenuse side, and a side. That will be the condition. And if you look at 5 as well, You've got 30 degrees. You also have 30 degrees. You've got a side and a side. Side and a side. So the two. All right. Now the two corresponding sides and an angle. So you'll have side, angle, side. And of course, the same goes for the last one. If you can look at the kite that we have there, it is divided into two triangles. Who can tell me what are we given there in that triangle? What do we have? Information that is given. Triangle, the two triangles, XY, XWY, and XZY. Again, you are given two angles there which are equal. Angle X1 and angle X2 are equal. And then you've got the side there, the two sides, corresponding sides. And of course, the other pair of sides, which are equal. Then in this case, you can also make a conclusion that triangle XWY will be congruent to triangle XZY. The reason being, you've got a side, a pair of sides, pair of angles, equal angles, and another pair of equal sides. That makes us to conclude now that the two triangles are congruent. To wrap up once again, congruency. Two triangles are congruent if and only if they have the same shape and the same size. So you need to be able to prove or use any given information that you have, whether it's corresponding sides or corresponding angles. You need to be able to identify the given information in order to use it to the best of your ability to prove congruence. Now, this brings us to the end of today's lesson. And of course, those are the reasons that are there for the activities 1 up to 6. We have proven congruency there. What we need to do now is to look at the following homework. Again, we are going to state whether the pairs of triangles are congruent or not. And if they are congruent, just give us the condition for congruency. You've got pairs of triangles there, which I think if you can take a picture there, work on this congruency. And of course, if you have a question, you need to send me a WhatsApp, and I can send you the homework via WhatsApp as well. And let's not forget to visit the links that are helpful to continue taking more shapes, more examples of congruency. And let me take this opportunity to invite you to our next lesson, which will be tomorrow, where we will carry on with 2D shapes. Of course, my number is on the board there, 082 623 2148. You can follow us on social media as well. On Twitter account @AfricaTeamGeeks. Of course, also on Facebook, you can get a link for Africa Team Geeks. The DBE website as well is very helpful. Thanks to our sponsors as well, MS Sora. Until we meet again tomorrow, thank you very much indeed. Have a nice day.